ln mod x log mod x plus c. So that's my answer going to be. I just have to replace v by y by x. Remember, this is what I am doing. Log of mod ln of mod x is actually log x to the base of e. So when I replace v by y by x, my answer is minus cos of y by x is equal to minus ln of mod x plus c. So that's my general solution, but I had a condition given to me that y of 1 is equal to pi by 4, which implies when x is 1, y is pi by 2. So I substitute these values into my previous equation, the general solution. Minus cos pi by 2 is equal to minus log 1 plus c. Log 1 is 0, cos pi by 2 is 0, so c works out to be 0. I substitute that back into my general solution, which gives me this, and I take away the negative signs, and that's my answer. Another question. Find the general solution of this differential equation. The first thing is we see whether this is roughly a homogeneous differential equation. I have x square y dy by dx given differential equation is x square y into dx minus x cubed plus y cubed into dy is equal to 0. If we check the degree of each terms, x square y degree is considered as 2 plus 1, 3, and the other two terms have degree 3 and 3, and therefore we know that this is a homogeneous differential equation. But I try to make dy by dx as a subject, and for that I shift the first term x square y to the other side, x square y dx to the other side, and dy by dx is made as a subject. So this is what I get. But to make this into a function of y by x, what I need to do is I divide each term by the highest degree x term, which is x cubed in this case. So when I divide each term by x cubed, the numerator gives me x square cancels off. I will have an x still, which makes it y by x. This x cubed by x cubed gives me 1, and this y cubed by x cubed now becomes y by x the whole cubed, which is a function of y by x, and we call that as equation number 1. This is now homogeneous, and therefore I say let y by x be equal to v. So y is vx, we differentiate, and this is what we get. So all these will go back into my equation number 1. So dy by dx is going to be v plus x dv by dx. The right hand side is going to be v by 1 plus v cubed. So this is what I get, and now I try to simplify this. The first step is to shift v to the other side, so it becomes subtraction on the right hand side, and then I take LCM. So when I take LCM, I cross multiply, then I open the bracket and try to simplify. So this is what you get, v minus v raised to 4 by 1 plus v cubed, plus v and minus v cancels, we get only v minus v raised to 4 by 1 plus v cubed. And at this stage I cross multiply both the ways. This 1 plus v cubed will come to the left side, dx will go to the other side. So that's going to make it look like 1 plus v cubed x dv is equal to minus v raised to 4 dx. I separate the variables now completely, get this v raised to 4 to the left side, so it becomes division dv. This x goes to the other side, makes it minus 1 by x dx. And then I of course integrate on both sides. Once the variables are separated, I integrate on both sides. But to integrate the left hand side, this term, what I did is I divide them separately by v raised to 4. So 1 by v raised to 4 is v raised to negative 4. And v cubed by v raised to 4 is 1 by v, which is fine with me because that is log mod v, ln mod v. So that's fine with me. So I don't shift that up. I keep it as 1 by v. While the first term I shifted to the numerator. Right hand side is minus integral 1 by x dx. That's also fine. I know the integral. So when you try to integrate it, v raised to negative 4 becomes, let's like x raised to n, and that becomes x raised to n plus 1 by n plus 1. So v raised to negative 4 becomes v raised to negative 3 when I add 1 to the numerator divided by negative 3. 1 by v is ln log mod v, log mod v, or ln natural log mod v is equal to minus ln mod x plus c. And I replace v everywhere by y by x, and that's my answer. We're going to look at another differential equation now. So that's the differential equation. I know it looks pretty complicated, but it already tells you that this is a homogeneous differential equation because you already have cos of y by x in there. The first thing is to make dy by dx as the subject of this equation. For that, I keep the dy term on the left side, that's this part, and the dx term I shifted to the right side and made dy by dx as a subject, and so this is what I get.